So we have the game and we have three choices for level difficulties. You could technically choose 4 or 5, but I feel like the game runs too slow at those levels, so we can choose 1 ply, 2 ply, or 3 plies. I'm going to choose 1 and then I'm going to choose 2 just to show the difference in the AI's ability. So here's 1. So if I put it at 5, the AI responds by just putting it in the first column because it doesn't recognize the score difference. And so then what I keep doing is I keep building a wider base because the AI is just going to keep building in the first 2 columns. So I'll build all the way through and then start stacking to build a wider base so I get not only the vertical and horizontal but also the diagonal scores for all of them, and it'll keep going in the future. And we'll show what the AI does if you get to a harder level. So if I put it at 5, now the AI is trying to counter my base building by building a base on top of it. So that not only do I not get the points for being on top, it's going on top of me to build its own base to go up on top. And then you can see it just kind of keeps building and trying to get the diagonals and the side-by-side points. So we're going to go over the classes that I have for the Simokogo project. So we have the coordinate, which is basically just an X, Y for where the tile is on the board. We have a pair, which is basically a pair of coordinates that when we're comparing 2 pairs for a score, we can keep track of that pair to see if it's ever been visited before. And then we have the node class, pretty simple, just has the parent, the board, the list of children, the depth of the node, and then it has a few things like the position of where the children for that node are. So, because we're building one child at a time, so if we've already built child in column 1, we know the next child we need to build is in column 2, etc. And then it has an alpha or beta value, which is labeled alpha beta. We have the board class. You can see here there's a default board constructor, a deep copy board constructor that takes a board from parent and creates that same board so you can modify it for the children. You have the add user piece and add AI piece. Basically, you're just differentiating between adding O and X. And then you have the get score differential. So you get the score differential of the entire board. So you're taking the AI score minus the user score. And then you're going to get the individual tile score. So that's used to get the individual tiles of each one, and then you add them up for either the AI or the user, depending on which one it is. And then you have the already visited function, which basically tells you whether or not a pair of tiles has been visited, so you don't have to repeat that when you're keeping the score. And then down at the bottom, you have a valid column to double check that that particular column is already full with pieces. Now we're at the main class, the Simokogo class. The main method is basically just getting the input of the level of difficulty from the user and then running it and then printing the end output. That's all that's in the main method. The run method basically just runs until the number of moves is 40. It prompts the user for their choice, gets it, adds the piece, and then does the AI turn. The AI turn is basically going to create a search tree to find the next best column to insert it in. So here we have the search tree class, and we'll start with the get best method because that's where it all starts. You add the root, and then you start searching the tree for a solution. In the search method, all you're doing is popping off the node, and then you're checking to see if it's a leaf node, or if it's not, you're going to build a child. The successor function will basically look at what column position is remaining to put in that child and build it. If the depth is an odd number, then you're going to put an AI piece in there. If the depth is an even number, you're going to end up putting a user piece because the turns are alternating and the user always starts first. After that, if you're in the evaluate function, you're just going to get the differential of the board. And then if that differential is less than the immediate beta, you're going to go ahead and update that immediate beta and then call the alpha beta pruning function to see if you can eliminate some of the nodes from being even built in the future. In the alpha beta, you're going to take the parent node, you're going to take the alpha, the beta, and then you're going to take whether or not you're looking for the maximum value. If you're looking for the maximum value, you're trying to see if the beta you have is greater than your alpha. If it is, great, go ahead and update it. If it's not, then go ahead and add the next child to see if anybody else is bigger, and you'll end up being able to cut off a block there. Same idea goes for the minimum player. You're looking for an alpha that's smaller than the beta that you have. If it is, that's great. Go ahead and change the value and see if you can propagate upwards. If not, then you're going to go ahead and add the parent of the parent. So basically, you're going to go through the remaining children and you're cutting off that block.